Namaste and a very good morning to all of you. My name is Mithun, and in today's video we'll be looking at how to execute a decision tree model using the Orange software. Let me first show you the data set that I'll be working on. This is the famous iris data set. You can see here there are 6 variables. The first variable is the flower ID. You have flower characteristics like sepal length, which is measured in centimeter, sepal width, which is again measured in centimeter. You have petal length and petal width. And the last variable is species. I want to use the species variable as the dependent variable, and the variables like sepal length, sepal width, petal length, and petal width as the independent variables. Now, what is the sample size in this data set? When you look at the last row, it says 150, which means that there are 150 flowers. And for each of these flowers, we have the corresponding species. How many species types are there? To understand this, I'll just apply a filter. And once I apply a filter, you can see the 3 different species of flowers, namely setosa, versicolor, and virginica. So these are the 3 species of flower. So the dependent variable has 3 categories: setosa, versicolor, and virginica, and we will be using the flower characteristics like sepal length, sepal width, petal length, and petal width to predict which species does a particular record belong to. So with this introduction about the data set, let me jump to Orange software. So this is the Orange software. You can see here, this is a blank canvas because right now I have not created any workflow. And to the left-hand side screen, you can see different widgets. You can use these widgets to create a workflow. Let me begin by loading the iris file. How do I load the file? You can click on the data option. The very first widget here is what is called as a file widget. What is a widget? It is a computational unit of Orange. Let me click on the file widget. You can see here the widget appears in the canvas. Now to open up the file widget, let me double click and then choose the browse option. Once I choose the browse option, it takes me to desktop statistics R sample files. This is the location of the file. And in this location, you can see the iris file. So I want to load this particular file. So I'll just choose the file and click on open. Now, let me click on reset. You can see all the variables, the data type, and the role being displayed for each and every variable that is present in the data set. Now, for the first variable ID, it is a numeric variable, but the role that Orange assigns is that of feature. I want to remove this from feature and see this and assign it as skip. I don't want to use the ID variable henceforth. The next 4 variables, that is the flower characteristics, are all numeric. So which means that Orange does a good job of guessing this as numeric. I want to use them as feature. The last variable, namely species, is a categorical variable. And the default role is that of feature. I'll change this to target. Now, I will be building a decision tree model. Decision tree model is a supervised learning technique. When I say supervised learning technique, here you have a dependent variable and a set of independent variables. The variable species is the target variable, and the flower characteristics are the independent variables. As you can see here, there are 3 species, namely setosa, versicolor, and virginica. Once I make these selections, I can click on the apply option. So these changes that I've made will be applied in the subsequent widgets. Let me close this. So at this stage, I have loaded the data set. If you want to display the contents of the file, what you can do is you can choose the widget, which is called as data table. Let me click on data table and establish a connection between file and data table. Now, the information will propagate from the file widget all the way to the data table. Let me double click on this. You can see here species. This is the name of the flower. Sepal length, sepal width, petal length, and petal width. As you can see here, these are the 5 variables that I want to work on. You can, if you want to, visualize the numeric values. The length of the bar indicates the magnitude of the value. For example, if you see large bars here, it means that that particular cell has a large value. If I scroll down, you can see here, there are different records which are being colored in different colors. All the setosa flowers are colored in blue. Versicolor flowers are colored in red. And if I scroll further down, you can see the Virginica flowers are colored in green. This is just a visual representation of the values in the cell. Let me close this. So what I've done at this stage is I have loaded the file in orange, and after loading the file, I've displayed the contents of the file using the data table widget. Now, even before we build any machine learning model, we will do a basic level of EDA or exploratory data analysis. There are many ways in which you can do an exploratory data analysis, but for the purpose of this video, I'll keep it very simple. I will just choose a scatter plot. Now, how do you construct a scatter plot? You'll have to scroll down. You can see different options here like visualize, model, and evaluate. I will choose the visualize option, scroll up, and you can see scatter plot option being displayed. Let me choose the scatter plot, and I can drag this here and establish a connection between the file widget to the scatter plot. This will help me construct a scatter plot. Let me open up the scatter plot. You can see here, by default, in the x-axis, we have chosen petal width, and in the y-axis, we have again chosen petal width. I want to choose a different variable, which is, let's say, petal length. Now, as you can see, the y-axis is petal length and the x-axis is petal width. When you use the petal length and petal width, what happens? You see all the blue color circles closer to the origin, and at the other extreme, you see all the green color circles. The blue color circles, if you look at the legend, correspond to setosa. The green color circles correspond to virginica, and the red ones correspond to versicolor. So how do we interpret this scatter plot? Setosa flowers mostly have a lower value of petal width as well as petal length. If you look at the red color dots, which correspond to versicolor, the versicolor flowers have a moderate value for petal width as well as petal length. And finally, what you have is all the green color dots, which are at the extreme right-hand side, indicating that the virginica flowers have a higher value for both petal width as well as petal length. So setosa flowers, lower values, and then virginica flowers have higher values for petal length and petal width. One important observation here is when you use the petal characteristics, you are able to separate the setosa flowers easily. When you build a model, this scatter plot gives you an early warning signal as to what you can expect at a later stage. That is, when you build a model, please don't be surprised if petal length or petal width come up to be important variables. Now, this is a scatter plot using petal length and petal width. What happens if I change the x-axis to sepal length? We are able to separate setosa flowers, but it's not so easy to separate the other two species of flowers. In the y-axis, I will be choosing sepal width. What happens again? It is the same story. It's a lot easier for us to separate the blue color circles, which correspond to setosa flowers. Setosa flowers, very easy to separate. But when you look at this entire region, you see a mixture of red and green color circles, indicating that it is not going to be easy for us to separate the versicolor and the Virginica flowers. So sepal characteristics are not doing a good job of separating the species of flowers, but when we use the petal characteristics, we can expect good separation. Now with this initial bit of EDA, what I'll do is I'll close the scatter plot and I'll proceed with the next step. Now this is an optional step. What we're going to do at this stage is we're going to use a widget which is called a select column. So let me click on data, and here you can locate the select column widget. Let me choose the select column, and what I'll do at this stage is to establish a connection between the data table and the select column. Let me open up select columns. What do you see here? Under the features list, you see all the flower characteristics, and the target variable here is species. Now, if you're not okay with this, you can just reset, and now nothing is happening. This is because in the file widget, I've already specified the species variable to be target and the flower characteristics as features. This is what I want. I want to use all the flower characteristics as the independent variables, and I want to use the last variable species as the target variable. Let me close this. This is the third step. We have loaded the data set. We have displayed the data set. We have done a basic level of EDA with scatter plot. Now we have specified the role of the independent variables as well as the dependent variable. With this, we are ready to build our decision tree model. Now at this stage, I'd like to mention 5 important points about a decision tree model. First, a decision tree model is very simple and easy to understand. Second, a decision tree model helps us in feature engineering. Not just in feature engineering, it also helps us in model building. Third, when we build a decision tree model, we are not making any assumptions about the distribution of the data. So these are distribution-free algorithms. Fourth, a decision tree model requires less time to clean the data because a decision tree model is less affected by the presence of missing values and outliers. And the last point is that a decision tree model can handle mixed data type. When I say mixed data type, what I mean is that irrespective of whether you have a scale variable or a categorical variable, you can supply it into the decision tree algorithm and you can get predictions for each of these variables. Now, these are some of the distinct advantages of a decision tree model, which makes it very, very popular algorithm. Now, with this background, let me make a move on to building a decision tree model. Now, to build a decision tree model, let me scroll down, and you can see here below the visualize property, you see what is called as model. Let me click on the model option, scroll up. Orange displays the different models that are available. I will choose the option tree. Now, the tree widget appears in the canvas. I can establish a connection with the tree widget. You can open up the tree option. You can see some of the parameters which you can sort of control. For example, if you want a binary tree, you can make sure that you click on the first option, else you can unclick on the first option. Minimum number of instances in the leaf can also be specified. The third option here is do not split subsets smaller than. I've given the option of 1. You can either increase or decrease. This is entirely under your control. Limit the maximal tree depth to 5. Now, we don't want a tree which is very, very deep because it leads to overfitting problem. The default option is 5. This is entirely under your control. You can reduce this. And you also have the stopping criteria for the algorithm, which reads here as follows: stop when the majority reaches 95%. We can play around with these parameters. I'll just close this. What I'll do is I have not changed the default settings drastically. I have retained the default settings more or less. Now with these default settings, I want to visualize the decision tree model. How does the decision tree model look like? Now to visualize the decision tree model, you have to scroll up, choose data. In fact, data will not help us, my apologies. I'll have to scroll down and choose the option visualize. You have evaluate, okay. Right, you have the visualize option here. If we choose visualize, and here the option here that you see is tree viewer. So the tree viewer appears here. I can establish a connection from tree to tree viewer. Now, if you want to view the tree output, you can double click on the tree viewer, and you can see here, this is how the decision tree appears. Now, what do we see with this decision tree? What we see is the target class that is specified is Virginica. I will just say none. It's a lot easier to differentiate the nodes with this selection. You can see here the blue color node represents setosa, the red color node represents versicolor, and the green color node represents Virginica. Now, what you see at the parent node is that petal length is identified to be the best predictor to classify the flowers. I repeat, petal length in centimeters is found out to be the best predictor to classify the flowers. If you recall the scatter plot that we had done, petal length was doing a good job of separating the different species of flowers. That idea is expressed in the decision tree as well. Petal length is the first best predictor. Now here you see that there is a branching off. To the left side, what you see is 1.9. How do you interpret this? If the petal length of the flower is less than 1.9 centimeters, you can say such a flower is setosa, and you are able to get all of this right. So 50 out of 50 setosa flowers have been correctly predicted with this rule. So you have the first rule, namely petal length less than 1.9 centimeters will always be setosa. That's your first rule. So next time anybody gives you a flower and you want to identify whether this particular flower is setosa, versicolor, or virginica, all that you need to do is look at the petal length. And if it is less than 1.9, you can be confident and you can say that such a flower is setosa. Now, what happens when the petal length is greater than 1.9? You have to look at the other branch. When the petal length is greater than 1.9, it is not so easy for us to make a decision because we need more variables. So not just petal length, we need to look at the next variable, that is petal width. So petal length is greater than 1.9, and if the petal width for a flower is less than 1.7 centimeter, here 90% of the flowers predict versicolor. Very, very important. 90% of the flowers predict versicolor. What happens when the petal length is greater than 1.9 and the petal width is greater than 1.7? They predict for virginica flowers. So this is a simple decision tree model. Now what you can do is you can further click on this particular circle and you can see a couple of branches are shown here. How do we interpret this? Let's go back to the parent node. You see petal length greater than 1.9, petal width lesser than 1.7, petal length again less than 4.9 predicts versicolor. And if the petal length is greater than 4.9, they predict for virginica flower. So this is how a decision tree helps us identify which flower does a particular record belong to based on the flower characteristics? Very simple. If the petal length is less than 1.9, it's a straightforward case. You don't need any additional variable. Straight away, you can say that it is setosa. Problem comes when the petal length is greater than 1.9 because you need additional predictors to classify the flower. Petal length, when it is greater than 1.9, you also have to look at petal width. If the petal width is greater than 1.7, you can say it is virginica. What if the petal width is less than 1.7? You have to look at petal length again. If petal length is less than 4.9, you can classify the flower as versicolor. If the petal length is bigger than 4.9 centimeter, then you can classify the flower as virginica. There are a couple of options that you have. You can see here, as the number of classes increase, it becomes a bit difficult to classify. So if you want to easily highlight a specific flower, what you can do is you can click on the drop-down menu, and let us say you want to see only setosa. You can see only this particular node will be highlighted. So it becomes a lot easier for us to identify which route do we need to traverse to pick up setosa flowers. Let's say I want to see all those rules that correspond to versicolor. So I can choose this. All the red ones correspond to versicolor. And finally, if you choose virginica, you can see some of these nodes which are highlighted in green. All these are rules corresponding to the virginica flower. So it depends upon the business and the business requirement. Based on the business requirement, the target class can be identified. So to summarize the discussion that we've had, today we saw how do we load the data set in Orange. Secondly, how do we construct a scatter plot? And thirdly, how do we build a decision tree model? With this, I have come to the end of today's presentation. If you have liked this particular video, I request you to subscribe to my channel, and I'll see you in my next video. Thank you very much. Have a great day.